It is Wednesday, April 1st, so happy April. We finally made it here. You should have already watched your Algebra 1 video, so if you have not yet watched your Algebra 1 video, you need to go back and do that. So watch that first. In there, you started section 12.4 where you are multiplying rational expressions. So I am going to go over rational multiplying with you in this example and in the next one. So I'm going to do two examples with you that will just mimic what you did in Algebra 1. And then just like last time, you will have an assignment on Canvas. You can take it up to 3 times and I will take your highest score. When you are multiplying rational expressions, a couple things that are important to remember. First of all, you're going to multiply straight across. So when I say that, what I mean is you take top times top and bottom times bottom. With that said, another thing you need to keep in mind is that you can reduce or cancel 2 directions, diagonally and vertical. So vertical means up and down. So that's important to remember. And then the third thing that I want you to remember is you always want to factor first. Okay, so let's look at our first example here and see what we have going on. Okay, so as I look from piece to piece to piece here, I'm looking for what can I factor or break down. That's what I want to look at first. So if I look at this first fraction, in the numerator I have just 3, which is a monomial, so I'm going to leave that alone. But in the denominator I have 21n squared plus 7n. So remember, when you're factoring, the very first thing you always look for is a common factor. So 21 and 7 are both divisible by 7, and they both have an n in common as well. So we are going to factor out 7n. That would be the greatest common factor in that denominator. And remember, when you factor something out, that means that you are dividing by it. So 21n squared divided by 7n would leave us with 3n. And 7n divided by 7n would leave us with 1. So that denominator becomes what you see on your screen. Now we're multiplying. So as I jump over to the second fraction, I see 9n squared plus 3n in that first numerator. So 9 and 3 are both divisible by 3, and they also both have an n in common. So now 9n squared divided by 3n would leave you with 3n, and 3n divided by 3n would leave you with positive 1. And then this final denominator is a monomial. Remember, monomial means just a single piece, so we're not going to break that down. So now as we look for things that will cancel or reduce, again, back up here, remember that I said diagonal and vertical. So on the diagonal here, I have a 3 here and here. So those will cancel each other out. And then on the opposite diagonal, I actually have 2 different things that will cancel. This 3n plus 1 will cancel with this 3n plus 1. And then even though 3 and 7 cannot cancel, the n's that they both have can cancel out. So now if I look at what I'm left with, remembering that up here I had told you that we need to make sure that we multiply straight across. So if I look at what I'm left with here, across the top, the only thing that I still have in the numerator or on top is a 3. And then in the denominator, I have a 7 and an n. So 7 times n is 7n. This would be your solution to that multiplication problem. All right, let's go over one more of these before you hopefully attend to your work for my class. Okay, so if we look at this one, you can see that you have a quadratic expression in the numerator of the first fraction, but that quadratic expression is a little different than the one that you had in the last one because it is a trinomial. It has 3 terms, and those 3 terms do not have anything in common. So we are not going to be able to just factor out a common factor, but we are going to be able to factor that. So again, just like last week, I'm going to use box method here. If you use a different method, by all means do that. Just make sure that you get the same answer that I have. So if we're going to factor this, there's technically a 1 here, right? So I need 2 numbers that multiply to be 5. And those same 2 numbers need to add to be this. So they need to add to be -6. So what would be those 2 numbers that multiply to +5 and add to -6? Hopefully you're coming up with -1 and -5. So as we look at setting this up then in the box, here's our box. Remember, in the upper left, we would have our leading term, so that's n squared. And in the bottom right, we would have our constant term, so that's 5. And then the other 2 boxes are where we use our factor pair from here. So -1n and -5n. And we're going to now look for what we can take out. So in this first column, n squared and -5n have a common n. And this next one, -1n and 5, they don't really share a common factor. So remember, there's always a common 1. And because this box where the arrow left is negative, this is going to be a -1. Over here, n squared and -1n, they would share a common n. And then finally here, -5n and 5 would share a common 5. And again, because the box where the arrow left had a negative, this becomes a negative as well. So as I move back over here to the main problem, that means that I can rewrite that numerator as n minus 1 times n minus 5. Now the denominator of that first fraction is n minus 1, so I would look for a common factor there. They don't share a common factor, so I'm just going to leave that as n minus 1. And then times, over here, this second numerator is just 1. That's a monomial, so it stays the same. And the second denominator is n minus 7. Again, n and 7 don't share a common factor that I can take out, and it's not n squared, so it doesn't need to be factored. So that's going to stay n minus 7. So now, if you remember from the last page, what I said is you can reduce vertically or diagonally. So if you look here, hopefully you notice that vertically, these n minus 1s can cancel out. And there's nothing else that will cancel. So as we look for our answer, in the numerator, I have n minus 5 times 1, which would just be n minus 5, because anything times 1 stays the same. And then in the denominator, the only thing I still have is n minus 7. So this would be your solution. All right, so looking at just one more thing really quick to talk about here. If you were given something that looked like this, so if you were given something like that, so the second part of that one looks kind of strange because it is not a fraction. But technically it is, and that's going to be important for you to realize This is technically a fraction. I know you saw at least one like this in Algebra 1. It has a denominator of 1. It will help you to write that denominator of 1 down. So if we work our way through this one, if we look at the first numerator here, 3x minus 6, those share a common factor of 3, so we want to factor that out. If we divide 3x by 3, we have x, and negative 6 divided by 3 would give us negative 2. The denominator is a monomial, so I'm going to leave it alone. Over here in the second fraction, my numerator is also a monomial of 6x, so I'm going to leave that, and the 1 stays the same as well. So there's not a whole lot here that's going to cancel out, remembering that you can cancel vertically or diagonally. So vertically, I can take out these 3's, but there's nothing else that I can see. So now as I go to write my answer, in the numerator, I have two things. I have x minus 2 times 6x. You do not have to multiply those together, so your teachers are not going to expect you to do that. But I will tell you that normally you're going to see that monomial, that single piece, coming first. So you would be more likely to see it like this than the form that it was written in. And then your denominator is technically 1. And remember, we don't really need to write a denominator of 1. So your answer in simplest form would just look like this. All right, well, good luck today. I hope that it goes well. If it doesn't, remember you can retake, and also remember that you can message me on Canvas Messenger, and I'm happy to help you. If you've already taken the quiz once and you feel like you don't understand what you messed up, you can always just message me that, and I can take a look at my end at what you've missed and try to help you understand your mistakes. I hope you're doing well.